Hello everyone, welcome back to my channel, Day One. There. So today we are going to talk about data streaming. So before we get into key features of a data streaming, I would like to ask a quick question. You might have experiences in your career, such as if you have more than 10 years of experience, then definitely you might have used messaging platform such as IBM MQ or Sonic MQ, or you might have used Rabbit MQ, different messaging platforms. I'd love to hear your experience, how you have been migrated or transformed from your messaging platforms to streaming platforms. So to keep it in a context, uh, it's really allowed to hear your feedback and really appreciate if you can post it on comments of this video, or maybe you can put it in a Google Forms. Allowed to hear your transition, how the learnings went through. So keeping aside, and let's jump in our data streaming platform. What we're going to talk about this is. So to start with this is a powerful technique for processing and analyzing data in a real time. So some of the key features for when I'm selecting a data streaming platform, definitely one of them first place my key feature here is going to be continuous flow. Just unlike traditional batch processing or data streaming continuously receive and process the data as it generated. So what does that mean, processing a data here? Maybe I can call out during a solution design, which I'll try to release new video along with this the same week as a product. Okay, so this allows immediate response and some insight information into the data. And the second key feature is unbounded size. Data streams are technically, in terms of a theory, it's more infinite in length, and as new data arrives continuously generate from your source systems, and this also requires some processing techniques compared to infinite data sets. And the third one is a high velocity. Technically, this is where data streams often generated data at a higher rate and require efficient processing algorithms and infrastructure to keep up with the resilience. Data streaming enables real-time analysis, and also it has to be highly available. The changes in a volume, format, or a content. This required some processing system to be adaptable and resilient. And real-time analysis, as called out in a previous bullet point, especially where your decision making allowing for immediate reactions to events and trends in your data. Okay. And when you're doing batch processing or and data streaming offers significant low latency, so providing a faster insight and responses. Data streaming systems are designed to scale horizontally. If you guys are remembered during a container time, I did called out horizontal pod scalability. So it's pretty much you can scale horizontally here. So if you're has a question, just give me a comment there. Maybe I'll do a separate video talk about purely horizontal scaling. Uh, so allowing them to handle increase the data volumes by adding more processing units. By default, data streaming systems are built with a fault tolerance in mind, ensuring a continuous operation even if individual node fails. Yes. And complex event processing, this is also, you might have heard some terms like CEP, which is abbreviation of a complex event processing. Streaming systems often include capabilities for complex event processing, enabling the identification of patterns or correlations in the streaming of a data in a real time. So keeping these features collectively enables organizations to process, analyze, and derive insights from a high velocity data streams, facilitating real-time decision making, monitoring, and predictive analytics across various domains such as finance, IoT, healthcare, and technology areas. So let's look at our few products which are available in the market to support your data streaming. As most of you are heard term called Kafka. If your in your organization is migrated from MQ products like IBM MQ or RabbitMQ, and there's another product which is available from same Apache organization called Pulsar. This is a higher version of next version of Kafka, because enterprise-wide and most of our organizations were aligned to a Kafka. Pretty much Pulsar and Kafka falls under same category of a data streaming, the products. But Pulsar has more higher features, and Kafka has a pretty higher support from companies like called Confluent and IBM and Red Hat. So they do most of our enterprise customer support organizations or IT services teams supports within Kafka, and it's highly used by even cloud providers. So keeping aside of our products, what we have it. So let's jump into our cloud providers. We do have Azure supports called as Streams and a Kafka. So Streams is a Azure's native product, and Kafka is they install as a self-managed as a you can do it as well as a managed services. This come from a Kafka cloud providers. So similarly, AWS has called a Kinesis, which is their cloud uh, proprietary product, and coming to Kafka, it supports self-managed and as well as managed services. And coming to the Google, they call as a PubSub. They do have a streaming platform, but it's the terminologies are different because they are keeping Pub and Sub, which is a one-to-many of a solution or a many-to-many. So Kafka is more used as a you can do it in a one-to-one or many-to-many. The way you are giving your certificate, SSL certificates to your consumer of your Kafka messaging. All right. Keeping it aside all our stuff, and I hope you had learned something new about our platform. These are especially key features which I go back and look at if I'm evaluating a product. All right. Uh, have a wonderful day. And if you have any questions, post it back in my channel.